So what we can learn from this example here. So this example learns us there are different ways or different methods we can apply to Rankine cycle, and by any of these methods we can increase the efficiency. Okay, and how this can happen? So this can happen by any modification you can do to Rankine cycle, and this modification will result in increasing the average temperature at which heat is transferred to the working fluid in the boiler, TH. If you can increase the average temperature that the fluid will have or will increase to this temperature at the boiler, or if you can decrease the average temperature at which heat is rejected from the condenser at TL. If you can increase TH or you can decrease TL, then the efficiency will increase. This can happen, we can increase TH or decrease TL by any of these three methods. If you can lower the condenser pressure, so if the condenser operates at 15 kilopascal, make it operate at 10 kilopascal. This will increase the efficiency. If you can superheat the steam to higher temperature, the outlet of the boiler, if it's 300 degrees Celsius, if you can make the outlet at 400, 500, 600, then this will increase efficiency of the cycle. If you can increase the boiler pressure, the pressure at which the boiler is operating, if you can increase this pressure, then you can increase the efficiency. Let's see these like options on graph. So we have this option. Let's assume we have originally this cycle. We have 1, 2, 3, 4. We will operate the same cycle, but at the same time we will lower the condenser pressure. So what we mean by lower the condenser pressure, this is the line that representing the condenser. So we will decrease the pressure. We will make this line like comes like lower. So instead of point number 4 to be here, this will be 4 dash. This will be the new point, the outlet of the turbine. And instead of point 1, we will have 1 dash here. So this will be the new line that representing the turbine at lower pressure. And what is happening here? So here we have a new cycle. This cycle represented by these points, 1 dash, 2 dash, 3, 4 dash. If you compare the area between these 2 points, so originally this is the area we have. In the original cycle, this is the area that representing the network obtained from the cycle. But if we decrease the condenser pressure, so we have this area as well. Plus the original area, so are increasing the area, so are increasing the amount of network obtained from this cycle, so this means we are increasing the efficiency of the cycle. Clear? Make sense? The other option, if we have this cycle, let's assume the original cycle, this is this one. 1, 2, we have 3, and we have 4. This is the original cycle we have, and this is the original network obtained from this cycle. So here the option, if you increase the pressure of the boiler, so what will happen? So we'll have new points representing the cycle. So point 1 will be the same. Point number 2, it will, instead of it will be 2 dash. Instead of 3, we will have 3 dash. Instead of 4, we will have 4 dash, and this will be the network obtained from the new cycle. So if you compare these two regions, you will see that we have this orange region, it's like cutted or subtracted from the original cycle. So we have this area represent the decrease in work cycle, but we have a green area here added to the overall area, and this represents an increase we have. And if you like can quantify each one of them, you will find that the amount of increase more than the decrease we have. So in general, increasing the boiler pressure, this will result in increasing in the network and increasing in the thermal efficiency. The last option we have, if we can superheat the steam from the boiler at higher temperature. So again, this is the original cycle. 1, 2, 3, 4, and this is the area representing the network. If you superheat the steam means instead of having the boiler at this point, we will have the boiler outlet at this point. So point number 3 will be shifted to here. Point number 4 will be shifted to here. So what is happening? We have all of this area representing an increase of the network obtained from the cycle. So we are increasing the amount of work obtained from the cycle, and you are increasing the thermal efficiency of this cycle. So in general, we have 3 methods that we can use to increase the efficiency of Rankine cycle. The first one is to lower the condenser pressure, increase the boiler pressure, or superheat the steam, like obtained or exiting the boiler at higher temperature. Is this clear? So this is, again, everything we have for Rankine cycle. So Rankine cycle, we have it here. We have this example. And we know that how we can analyze the energy we have in Rankine cycle and the method that we can use to increase the efficiency of Rankine cycle. Here we have, for these methods, we have 3 methods. As we said, we can increase the efficiency of them, or we can use any one of them to increase efficiency of Rankine cycle, but there are some drawbacks for each one of them. So let's start with the first one. Here the original cycle, point number 4 is almost saturated vapor, right? So if you decrease the condenser pressure, so the outlet will be 4 dash. 4 is 100% vapor. 4 dash is mixture of liquid and vapor, right? And this is an issue we already faced with Carnot cycle. So we increase the efficiency of Rankine cycle, yes, but we have the same problem. We have mixture, and this mixture exists in the turbine and will go to the condenser. For this method here, we have the outlet of the boiler is point number 3, and here I'm superheating it to 3 dash. Not all the material of construction can withstand this higher temperature. So theoretically, this is a good idea, but this necessitates you to use like a special material of construction to be able to withstand this higher temperature. Some materials can be collapsed with higher temperatures. Okay, so this is one limitation of this option here. And here, for this one, as we said, this is the original point, number 4. This point is shifted here to 4 dash. So we are increased the boiler pressure, we are increased the efficiency, but here originally we have point number 4, more vapor, it's shifted to 4 dash, it's more liquid, so we are increasing like the mixture that we have here. And this is, we said, we don't need this. We need point number 4, point number 1 are very close to the 100%, 100 vapor. So any of these methods can increase the efficiency, but any of these methods have some limitations or can cause some issues or difficulties in the cycle itself.